At any cross-section within a wireway refers to any small portion of the wireway's interior area. It does not refer to the entire cross-sectional interior area of the wireway. The intention is to ensure that no small section of the wireway becomes overloaded, even if the overall wireway is not filled to its maximum capacity. Consider a 6-6 wireway. That any cross-section rule means you can't overload any 2-inch section within that larger wireway, even if the rest of the wireway has plenty of free space. The purpose is to prevent localized heating and potential insulation damage. The NEC addresses conductor derating in wireways to prevent overheating and ensure safe operation. Derating becomes necessary when the number of current-carrying conductors exceeds a certain threshold. For wireways, this threshold is 40 current-carrying conductors. If you have up to 40 conductors, no derating is required. However, when the number of conductors reaches 41 or more, derating must be applied. The National Electrical Code specifies the derating factors based on the number of conductors. For 41 to 60 conductors, derate to 80% of the conductor's ampacity. For 61 or more conductors, derate to 70% of the conductor's ampacity. To illustrate the derating process, consider a wireway containing 50 conductors, each initially rated for 30 amps. Because the number of conductors is between 41 and 60, a derating factor of 80% must be applied. The derated ampacity becomes 30 amps multiplied by 0.80, which equals 24 amps. Therefore, each conductor in the wireway is effectively limited to carrying a maximum of 24 amps. The NEC provides tables that list the allowable ampacities of conductors based on their size, insulation type, and temperature rating. These ampacity values are based on specific installation conditions, such as free air or conduit. When conductors are installed in wireways with a high number of current-carrying conductors, the heat generated by the conductors can raise the ambient temperature within the wireway, which reduces the conductor's ability to dissipate heat and lowers its ampacity. Derating factors are applied to compensate for this temperature increase and ensure that the conductors do not exceed the temperature rating. The National Electrical Code requires that the conductors be derated so they can safely operate in the wireway without overheating. The conductor ampacity is derated to 80% of its original value. This means that the maximum current that the conductor can carry is reduced by 20%. The ampacity derating factors are based on the number of current-carrying conductors in the wireway. Current-carrying conductors are defined as conductors that carry current under normal operating conditions. Grounding conductors and neutral conductors that only carry the unbalanced current from other conductors are not considered current-carrying conductors. The ampacity derating factors are applied to the allowable ampacity of the conductors. The allowable ampacity of a conductor is the maximum current that the conductor can carry without exceeding its temperature rating. The allowable ampacity of a conductor is based on its size, insulation type, and installation conditions. The ampacity derating factors are found in NEC Table 310.15 Cone. The table lists the ampacity derating factors for different numbers of current-carrying conductors. When applying ampacity derating factors, it is important to consider the effects of ambient temperature. Ambient temperature is the temperature of the air surrounding the conductors. If the ambient temperature is higher than the temperature for which the conductor's ampacity is based, the ampacity must be further derated. The ambient temperature derating factors are found in NEC Table 310.15 Burn. The table lists the ambient temperature derating factors for different temperature ranges. To determine the required wire size for a specific application, it is necessary to calculate the total current that the conductors will carry, apply any applicable ampacity derating factors, and select a wire size that has an allowable ampacity equal to or greater than the derated current. The total current that the conductors will carry is the sum of the currents of all of the loads that the conductors will supply. The ampacity derating factors are applied to the allowable ampacity of the conductors to account for the effects of multiple current-carrying conductors and high ambient temperatures. The wire size is selected based on the derated current and the conductor's insulation type and temperature rating. For example, Suppose a wireway contains 50 current-carrying conductors, each carrying 20 amps. The ambient temperature is 30 degrees Celsius. The conductors are type THHN, which has an allowable ampacity of 30 amps at 30 degrees Celsius. According to NEC Table 310.15 cone, the ampacity derating factor for 50 current-carrying conductors is 80%. The derated ampacity of the conductors is 30 amps multiplied by 0.80, which equals 24 amps. Since the derated ampacity of the conductors is 24 amps, a wire size with an allowable ampacity of at least 24 amps is required. According to NEC Table 310.16, a number 12 AWG THHN conductor has an allowable ampacity of 25 amps at 30 degrees Celsius. Therefore, a number 12 AWG THHN conductor is suitable for this application. It's important to consult the latest edition of the National Electrical Code NEC for the most up-to-date requirements and tables regarding wireway fill and conductor derating. The NEC is updated every 3 years, so it's crucial to ensure you're using the most current version. When dealing with electrical installations, always prioritize safety and consult with qualified electrical professionals to ensure compliance with all applicable codes and regulations. Improper installation or wiring can lead to hazardous situations, including electrical shock and fire. Consider a scenario where you have a wireway supplying power to several motors in a manufacturing facility. If the wireway contains a large number of conductors feeding these motors, it's essential to calculate the derated ampacity of the conductors to ensure they can safely handle the load. Neglecting to derate the conductors could result in overheating, insulation breakdown, and ultimately a system failure. Similarly, in a commercial building, wireways are often used to distribute power to lighting fixtures, receptacles, and other electrical equipment. Proper wireway fill and derating practices are crucial to maintain a safe and reliable electrical system. Ignoring these guidelines could lead to voltage drops, equipment malfunction, and potential fire hazards. The National Electrical Code provides comprehensive guidelines for electrical installations covering various aspects, including wiring methods, overcurrent protection, grounding, and equipment installation. Adhering to the NEC is crucial for ensuring the safety and reliability of electrical systems. Local jurisdictions often adopt and enforce the NEC, so it's essential to be familiar with the specific requirements in your area. Electrical inspections are conducted to verify compliance with the NEC and other applicable codes. These inspections help identify potential hazards and ensure that electrical installations meet the required safety standards. Wireways offer a convenient and organized method for routing and protecting electrical conductors. They are commonly used in commercial, industrial, and institutional buildings. Wireways are typically made of metal or non-metallic materials and are available in various sizes and configurations. They provide a continuous enclosure for conductors, protecting them from physical damage, moisture, and other environmental factors. Wireways can be installed horizontally or vertically and can be surface-mounted or recessed. They are often used to route conductors between electrical panels, equipment, and devices. Wireways must be properly supported to prevent sagging or damage. The support spacing is typically specified by the manufacturer or the NEC. Wireways must also be properly grounded to provide a safe path for fault current. The grounding requirements are specified in the NEC. When selecting a wireway, it's essential to consider the size and number of conductors that will be installed in the wireway, as well as the environmental conditions in which the wireway will be installed. The wireway must be large enough to accommodate the conductors without overcrowding. The wireway must also be suitable for the environmental conditions such as temperature, moisture, and corrosion. In addition to the derating requirements for current-carrying conductors, the NEC also specifies fill limitations for wireways. These limitations are intended to prevent overheating and ensure that the conductors are properly ventilated. The fill limitations are based on the cross-sectional area of the wireway and the size of the conductors. The NEC provides tables that list the allowable fill for different types of wireways. When installing conductors in a wireway, it's essential to follow the manufacturer's instructions and the NEC guidelines. The conductors must be properly supported and secured to prevent damage. The conductors must also be properly identified to facilitate troubleshooting and maintenance. In addition to the NEC, other standards and regulations may apply to electrical installations, such as those established by Underwriters Laboratories UL and the National Fire Protection Association NFPA. These standards and regulations provide additional guidance and requirements for electrical safety. It's important to stay informed about the latest developments in electrical codes and standards to ensure compliance and maintain a safe electrical environment. Continuing education and training are essential for electrical professionals to stay up to date with the latest technologies and best practices. By following the guidelines and requirements outlined in the NEC and other applicable standards, you can ensure that electrical installations are safe, reliable, and compliant. This helps protect people and property from electrical hazards and promotes a safe and productive environment. Electrical safety is a shared responsibility. Everyone has a role to play in preventing electrical accidents. By understanding the risks and following safety precautions, you can help create a safer environment for yourself, your family, and your community. Remember to always consult with qualified electrical professionals for any electrical work or questions. They have the knowledge and expertise to ensure that electrical installations are performed safely and correctly. Electrical work can be dangerous, so it's essential to take the necessary precautions and follow all safety guidelines. This includes wearing appropriate personal protective equipment (PPE) such as safety glasses, gloves, and insulated tools. It also includes energizing electrical circuits before working on them and verifying that the circuits are de-energized using a voltage tester. By prioritizing safety and following best practices, you can minimize the risk of electrical accidents and create a safer environment for everyone.